Hello everyone, I'm Fang Mei-Ling, the author of the poster. The title of the poster is Study on the Separation of Phycoerythrin by Fern by High-Performance Liquid Chromatography (HPLC). This study color pops such as sea grape or racemose is rich in cholerpin. The literature indicates that this substance has anti-inflammatory, anti-tumor, anti-tuberculosis, and plant growth regulation functions. This study intends to establish a set of technology that can automatically purify the phycoerythrin from several kinds of Pteridium algae after freeze-drying products with ultrasonic extraction. As the current standard product manufacturers do not sell pteridophyte standard products for analysis, if you want to develop pteridophyte, it is necessary to develop a reliable quantitative analysis system to establish various parameters for subsequent operations. This research is mainly divided into two parts. The first part focuses on the development of a set of automated extraction methods for Pteridium erythrin, replacing the traditional silica gel column purification method to extract a single component of natural substances. Purified Pteridium algae. The chemical structure, molecular weight, and purity of the purified product were confirmed by infrared spectroscopy (FTIR), nuclear magnetic resonance spectroscopy (NMR), and liquid phase tandem mass spectrometer (LC) per megasiemens. This method can save space. Consumables such as manpower and solvents are both environmentally friendly and quite flexible. This method can also be used in the future for other natural materials that cannot obtain standard products with single components. Next, the experimental design and process are described. Table 1 describes the conditions of the HPLC gradient analysis of the crude extract of Pteridophyte racemosus. 4 times are set respectively with a fixed flow rate, a temperature of 25 degrees, and a wavelength of 315 nanometers. The process description is as follows. Spread the racemosa on a freeze-dried plate. Place it in a freezer and pre-cool to -30 degrees Celsius. Take out the pre-cooled to -30 degrees Celsius Pteridium racemosus placed in a freeze dryer, freeze-dried at -30 degrees Celsius for more than 72 hours. Add 30 L of 95% ethanol to the freeze-dried Pteridium racemosa and shake at 75 degrees Celsius for 4 hours. The residue was filtered with Advantech No. 1.6 micrometers filter paper to obtain a crude ethanol extract of Pteridophyte racemosus. Put the ethanol crude extract of Pteridium racemosus into a rotary evaporator for concentration under reduced pressure to remove ethanol and water. The vacuum degree is 640 millimeters of mercury. After removing most of the ethanol from the initial 45, the temperature is gradually adjusted to 75 to remove moisture. After concentrating under reduced pressure, the crude extract of Pteridium racemosus was taken. 0.5 grams was added with 95% ethanol. 5 milliliters. After centrifugal filtration, 100 microliters was injected into the HPLC gradient analysis, and the material of each main wave peak was collected with a separatory collector. Analyze the components of the peaks collected by the separatory collector by HPLC-MS to confirm the retention time of pteridophyte. Confirm the retention time of pteridophyte in HPLC. Collect a large amount of pteridophyte in a separatory collector to prepare a standard product. A large amount of pteridophyte standards were collected, and the components were identified by NMR, FTIR and mass spectrometry again. The pteridophyte standard substance was injected into the HPLC at different concentrations to make a calibration curve. The raw material used to purify 4,900 grams of Pteridium cylindrica is dried at -30 degrees Celsius for 72 hours. and then extracted with 95% ethanol as the extraction solvent by ultrasonic extraction, filtration and concentration under reduced pressure. The total amount of crude extract of Pteridophyte racemosus is 116 grams, and the extraction rate is about 0.317. The crude extract solution of Pteridophyte racemosus was separated by HPLC liquid separator, and the collected solution was approximately 17.5 minutes in HPLC retention time. After deducting the positively charged ions in the mass spectrometer analysis, its molecular weight is 398, which is consistent with the molecular weight of pteridophyte. In order to further confirm whether the structure of Phycoerythrin standard product conforms to the molecular configuration of Phycoerythrin, Fourier-transform infrared spectroscopy and nuclear magnetic resonance analysis were also synchronized. In Fourier-transform infrared spectroscopy analysis, it can be confirmed that there are aromatic system-binding carbonyl functional groups from 1,600 cm-1 to 1,700 cm-1. And nuclear magnetic resonance analysis can also confirm the presence of aromatic hydrocarbons and heteroaromatic hydrocarbons at delta 7 to 9 ppm. Therefore, it was confirmed that when the HPLC retention time was 17.5 minutes, the collected liquid was Phycoerythrin. In this study, the simulated moving bed was used to continuously purify the Pteridophyte in Pteridophyte algae, and then to scale up and estimate. The following conclusions can be obtained. 1. After freeze-drying treatment of Pteridophyte racemosus, the extraction rate can reach 0.317 by ultrasonic extraction with ethanol. 2. The standard product of Pteridophyte cylindrica can be separated from the crude extract of Pteridophyte cylindrica by HPLC and separation collector, and the purity can reach 99%. 3. The molecular weight of Phycoerythrin standard product was 398 by mass spectrometry. FTIR and NMR analysis confirmed the existence of the structure of cyclic aromatic hydrocarbons and heteroaromatic hydrocarbons with Pteridophycoerythrin.